Hey team, it's Miss Kerr here. I am working on a problem to show you in our PowerPoint for our work. It's my first official YouTube video, so that's pretty cool, I think. So let's go ahead and just hop to it. We're talking about scale and scale factor and solving problems using scale ratios. And so I'm going to work one through the way we would do it in class, and I'm hoping that this is beneficial for you. So let's go ahead and start off. We have our question is, a scale on a map shows that 3.6 centimeters represents 12 kilometers. What number of actual kilometers are represented by 18 centimeters on the map? So our problem is broken up into two parts, and really every problem is. It's broken up into the info part, or the informational section that gives you all the info you need, and the question, which tells you what you're looking for. And so what we're looking for is what number of actual kilometers are represented by 18 centimeters. We're going to use the info here to help us here. But before we start breaking it down, we know that we're talking about scale. And scales are ratios. And when we're dealing with scales, we know that these ratios are proportional. So, for example, proportional, remember, is if I'm making pancakes for myself, I might use 1 cup of pancake mix. If I'm making pancakes for me and my husband, I might use 2 cups of pancake mix. So 1 cup per person. If I'm making pancakes for me, my husband, my parents, and his dad, I might, what is that? 1, 2, 3, 4, 5 people. I might use 5 cups of pancake mix. So they're proportional, 1 cup per person, just like a scale. So to solve this, we're going to need to create our proportion, or our two ratios that will be proportional to each other. One of our ratios is going to be the ratio we see in the problem, and that'll come from our info. So the ratio we see in the problem comes directly from our information. Our second ratio is going to be the ratio we want to solve for, and that ratio is going to come from the question. It's going to come from the question. So we have some numbers in our info section that will be in here. Those numbers are 3.6 centimeters and 12 kilometers. We have a number in our ratio that we want to solve for from the question part, and that's 18 centimeters. So that's great. We have our numbers, but where do we put them? Well, we're going to use this very handy dandy, will help you with every problem, little mock-up. Your drawing size is going to go on top. Your real life size is going to go on the bottom. And that's going to be true for both ratios. Drawing size on top, real life size on bottom. Drawing size on top, real life size on bottom. Well, how do we know what's the drawing size and what's the real life size? Well, let's look back up here. There's 2 ways we can tell. First off, I know that centimeters is a lot smaller than kilometers. I just know that. I've learned that. I can also Google which one's smaller. Now, it might not always be the case where we're looking for the smaller number to be the drawing size, but in this one, we know that centimeters would be in the drawing on the map because we cannot draw kilometers on paper. I mean, we could, it would just take a lot of paper. And I don't think anybody has time for that. So on our map, we're going to use the smaller measurement, which is centimeters, which means our kilometers is going to be our real life, or RL. So that's one way we can tell, just by using what we know already. Another way to tell is to look where it says actual. That word actual is a code word for real life. It's a code word. It means that the next measurement is going to be your real life measurement. And if you plug in real life for the word actual, it makes sense. What number of real life kilometers, okay, doesn't make real ton of sense, but it sounds nice, are represented by 18 centimeters on the map? So once again, it says on the map, meaning that these were drawn on the map. So actual kilometers is our real life. So in our ratio, we're going to have kilometers on the bottom and centimeters on the top. And that's going to be true for both ratios. Now we have to go back in our problem. 3.6 centimeters was in our info, so that goes on our ratio in the problem. And 12 was our kilometers, so that goes on the bottom. Again, this is the ratio that came from the info and is in the problem. This ratio is going to be what we solve for, and our information, some of it is going to come from the question part, or what we need to solve. Now, they gave us one number, they gave us the centimeters. They gave us 18 centimeters, but we need to figure out what kilometers is. I don't know what it is, so I'm going to give it an X. And now we can use our handy dandy cross multiply and divide strategy to figure this out. So I'm going to take 12 times 18, and that gives me 216. And guys, I did not just pull that number out of my head. I Googled it before I started this video. Make sure you're using a calculator to help you. So that was when I cross multiplied 12 times 18, I got 216. And now I'm going to divide by my third number, 3.6. And that's going to give me, again, I Googled this, 60. So my answer is, if I have 18 centimeters on the map, I'm going to have 60 kilometers in real life. Okay, crew, great job. I'll talk to you later.